If there was ever truly nothing, why is there something now? The question hangs at the edge of comprehension, an ancient echo that has haunted every mind daring to look beyond the veil of being. We live surrounded by the obvious: air, light, sound, matter. Yet, beneath the comfort of familiarity lies an abyss of contradiction. For if there was once absolute nothing, no space, no time, no energy, no thought, then how could anything have ever begun? From what could creation have borrowed its first spark? The very idea feels impossible, like imagining the color of silence or the shadow of a dream. And yet, here we are, witnesses to the aftermath of a mystery that should not exist. To think of nothing is to betray the thought itself, because the moment we imagine it, we have already filled it, with darkness, with emptiness, with something that exists enough to be called nothing. Even language collapses under its own paradox. The human mind cannot conceive of a true void, because our consciousness is the very act of being. So when we say nothing, what are we really describing? A quiet space? A blank canvas? A sleeping universe waiting to awaken? Each definition exposes our limitation, revealing that we are creatures built from something, trying to picture the absence of all things. Philosophers have wrestled with this riddle for millennia. Parmenides claimed that nothing cannot be, for even to speak of it gives it existence. Leibniz asked, with eternal simplicity, "Why is there something rather than nothing?" A question that still pierces through centuries of scientific progress, like a blade of reason through mist. Even modern physics, armed with equations and telescopes that can peer into the dawn of time, has not escaped this ancient trap. For when scientists wind back the clock of the universe, past stars, past atoms, past the cosmic microwave glow, they reach a horizon where space and time themselves evaporate into a silence too deep to measure. And there, beyond that edge, waits the most audacious question of all. Did the universe arise from nothing? In our human language, nothingness feels still and eternal, a perfect void. But in the language of physics, nothingness is far from calm. It is seething, unstable, alive with potential. The quantum vacuum, that invisible ocean of energy beneath reality's surface, never truly rests. Even in perfect emptiness, fleeting particles burst into existence and vanish again, borrowing energy from nowhere, returning it before they are caught. It's as if nothing itself cannot help but create, cannot help but tremble with the possibility of something. The universe, it seems, may have been born not from the silence of void, but from the restless whisper of uncertainty. But this explanation does not dissolve the mystery. It deepens it. For if nothing is unstable, then it was never truly nothing. And if it was never nothing, then perhaps the question itself is flawed. Perhaps there was no beginning in the sense we imagine, no moment when existence switched on like a light in the dark. Perhaps reality did not emerge from nothing, but from something that wears the disguise of nothing. Every scientific answer pulls the curtain only slightly back, revealing yet another stage of the impossible. What existed before the laws of physics? Before time? Before meaning itself? Each step backward feels like walking toward a mirror that endlessly reflects your own gaze, further, deeper, yet never reaching beyond the surface. And yet, we cannot look away, because hidden inside that paradox is the story of everything. The birth of stars, the spark of consciousness, the emergence of thought, all are entangled with that original moment when nothing, somehow, became something. We are the children of that mystery, living proof that the void was never empty, Nothing is unstable. Nothing explodes. And the universe, vast and ancient, may be the echo of that impossible detonation, the sound of nothing becoming aware of itself. What if, then, the greatest secret of existence is not how something came from nothing, but that nothing never truly existed at all? From the moment humanity opened its eyes beneath the stars, we have been haunted by an impossible question. What lies beyond everything? What remains when the lights of existence go out? Before we learned to measure time, before language gave shape to thought, we must have stared into the silent night and felt the pressure of a question we could not name. In that darkness, we sensed the presence of an absence, a void that both terrified and fascinated. Every civilization that rose from dust carried within it a hidden dialogue with nothingness, each trying to make peace with the unseeable womb from which all things were born. To the earliest thinkers, nothing was not a concept, but a fear. The absence of fire, the silence after thunder, the body gone cold. These were the first glimpses of the void. Primitive mythologies did not speak of nothingness as emptiness, but as chaos, a swirling sea before the world's first dawn. The Babylonians imagined Tiamat, a boundless water that existed before creation. The Egyptians spoke of Nun, a vast dark ocean out of which the first mound of land rose. In Hindu cosmology, the unmanifested Brahman existed before existence, silent and infinite, containing everything and nothing at once. Every myth, no matter how different, begins in the same shadow, an infinite before, a prelude of silence before sound. Yet these early people could not abide true absence. They filled the void with gods, with serpents, with words. They gave nothingness a face and called it creation's mother. The Greeks were among the first to turn this intuition into philosophy. They named the beginning chaos, not disorder as we know it, but a yawning gap, a cosmic chasm where no boundaries yet existed. From that gap emerged Gaia, the earth, and Uranus, the sky. Even here, nothing was not a negation but a potential. A pregnant emptiness waiting to unfold. The Greeks could not imagine nothing as total absence. It had to be a state before form, a stillness heavy with unborn worlds. But as thought evolved, some dared to strip creation of its myths. In the 5th century BCE, Parmenides declared that nothing could not exist. To speak of it, he said, was already to make it something. What is. What is not, cannot be. To him, existence was eternal and unbroken. The void was an illusion. Centuries later, his student's student, Democritus, proposed the opposite, a universe made of atoms moving in the void. The void, he claimed, was real, a necessary backdrop against which motion and matter could occur. In that paradox, Western thought was split forever, between two visions, one that denied the void and one that built reality upon it. Philosophy became a battleground for the nature of nothing. Aristotle could not tolerate an empty space. In his physics, nature abhorred a vacuum. To remove all matter from a region, he argued, would be to remove the possibility of motion itself. Existence required continuity, an unbroken fabric. But even as Aristotle's vision reigned for nearly 2,000 years, the cracks were already forming. In distant China, the Taoists spoke of Wu, non-being, as the root of all things. Laozi wrote, "All things in the world come from being, and being comes from non-being. For him, emptiness was not a defect, but a power, the invisible source from which existence flows. The space within a cup, not the clay around it, gives the cup its use. The hole in a wheel's hub, not the spokes, allows it to turn. East and west diverged, but both stared into the same mystery through different masks. The Greeks fought to define being as the opposite of nothing. The Chinese embraced nothing as the breath that moves through all being. Meanwhile, the Abrahamic religions approached the void with reverence and fear. In the beginning, Genesis proclaims, the earth was without form and void, and darkness was upon the face of the deep. Out of that darkness, God speaks light into being. The act of creation becomes divine speech itself, the word carving existence from silence. In the Hebrew tradition, creation is not emergence from chaos, but creation ex nihilo, from nothing. This radical idea forever altered human thought. It introduced the possibility that being might not merely unfold from something eternal, but might be willed into existence from absolute emptiness. To the theologians, this was proof of divine omnipotence. Only God could create from nothing. Humans could rearrange matter, but only a creator could summon matter itself. The void, once seen as chaos, now became sacred absence, the stage upon which divine will performs its miracle. Yet even within faith, the paradox festered. For if God existed before creation, was there ever truly nothing? Or was God himself the something that pre-existed all? The question slipped through language like light through fingers. In the Middle Ages, philosophers like Thomas Aquinas tried to reconcile faith with reason. They argued that God was the necessary being, the unmoved mover, and that nothingness was merely a state relative to creation. But this explanation comforted few and convinced fewer. Beneath it lingered a more troubling idea. Perhaps creation itself is an illusion, a transformation of something eternal into forms we can perceive. If so, then nothing is not the beginning, but an illusion born of limited sight. When the Renaissance dawned, the human spirit turned outward. The telescope replaced Scripture as our window into the unknown, and what we saw frightened us. Space, vast, black, endless. Was this the divine void the ancients had whispered about? Copernicus displaced humanity from the center, Galileo shattered the crystalline heavens, and Newton gave motion to the cosmos itself. For the first time, we had laws to describe the dance of planets and stars, but the space between them, the infinite darkness, still eluded comprehension. Newton called it absolute space, a stage upon which matter and motion play their parts. To him, the vacuum was real, but lifeless, a passive emptiness, yet even this new physics could not escape philosophy's shadow. Newton's opponents, like Leibniz, argued that space was not a thing at all but a relation, an abstraction, not a substance. They claimed the vacuum was a mental construct, a convenient fiction. In their debates, science replayed the ancient drama of being and non-being. Dressed now in mathematical garments, every discovery pushed us closer to the edges of understanding, and at those edges, the void always waited. The 17th century brought with it the first experiments on vacuums. Evangelista Torricelli, a student of Galileo, filled a glass tube with mercury and inverted it, discovering that a space formed at the top, a space that appeared to contain nothing. It was the birth of the barometer, and the proof that emptiness could be created. at least in part. Blaise Pascal climbed mountains with tubes of mercury, watching the empty space expand as air pressure decreased. Nature does not abhor a vacuum, he realized. She only fears it less than we do. In that thin, silent space above the mercury, humans had, for the first time, touched the edge of nothing. The Enlightenment carried this fascination forward. Voltaire and Descartes debated whether space could exist without matter. Descartes, unable to conceive of true emptiness, declared that the universe was a plenum, completely filled with substance, no gaps, no void. Even the airless regions of space, he argued, must be filled with an invisible ether. The ether became the modern air to Aristotle's continuous cosmos. It filled every crack, carried light, transmitted gravity, a comforting ocean that saved us from the terror of nothing. But as experiments grew sharper, that comfort began to erode. In 1887, Michelson and Morley set out to detect the ether's flow across the Earth. They found nothing, literally. Light did not need a medium to travel. The void, it seemed, was not full but truly empty. For centuries, philosophers had fled from this conclusion, but science now forced them to face it. Space was not an ocean. It was a vacuum. Yet that vacuum, far from being nothing, turned out to be strange beyond measure. Einstein showed that space and time are not passive backdrops, but dynamic entities. Gravity was not a force acting within emptiness, but the curvature of space-time itself. The void could bend, ripple, and warp. Even nothingness, under Einstein's hand, became alive. Space was no longer empty. It had geometry, energy, personality. The vacuum had structure. When quantum theory arrived, the illusion of nothing shattered completely. The so-called vacuum was revealed to be a boiling sea of probabilities, where particles flicker in and out of being. What we once thought of as emptiness turned out to be the most restless state imaginable. According to Heisenberg's uncertainty principle, even at zero energy, fluctuations must exist. The vacuum hums with ghostly activity. Out of this frothing quantum foam, entire universes could, in theory, emerge spontaneously. Nothing, once the symbol of stillness, became the engine of creation. And so, in a single sweep, science replaced the divine creator with quantum instability. Where religion saw the will of God commanding light from darkness, physics saw energy fields collapsing into existence from fluctuations in the void. One vision invoked purpose, the other invoked probability, yet both, in their own ways, bowed before the same mystery. Why should there be laws at all? Why should anything have the capacity to exist? Humanity's obsession with nothing has never been about absence. It has always been about origin. We ask what came before, because we are haunted by the sense that there must have been something, even if that something was nothing. We invent myths, gods, and equations not to escape the void, but to understand why we can never truly enter it. Every civilization has stared into that black mirror and seen its own reflection. The Greeks saw chaos. The Hebrews saw God. The Buddhists saw emptiness as liberation. The physicists see vacuum energy bubbling into being. And in every case, we find ourselves staring not into nothing, but into a deeper kind of something, one that refuses to be named. In modern cosmology, this ancient obsession has evolved into equations of terrifying precision. The cosmological constant, dark energy, the inflation field, all are whispers of the same truth. What we call empty space is not empty at all, but saturated with potential, with virtual particles, with possibility itself. The vacuum may contain the total energy of the universe, hidden in plain sight. Nothingness in this new light is not the absence of being, but the raw canvas of existence. And yet, the emotional wound remains. We still yearn for meaning, for a reason why there is something rather than nothing. Science describes the mechanism, but not the motive. It tells us how reality might emerge, but not why it does. The theologian answers with will. The physicist answers with chance. Between them, the human heart trembles. Perhaps our mistake was to treat nothing as a thing to be explained, rather than a silence to be felt. To define it is to confine it. To name it is to destroy its purity. The void, like death, cannot be understood from within life. And yet we cannot stop reaching for it, because it is the invisible mirror of our existence. Every time we gaze into the night sky, what we truly see is the impossible. Partnership between nothing and something, the cosmic dance that allowed us to ask the question at all. Every civilization imagined nothing differently, and each one shaped its gods around it. The Egyptians filled it with potential waters. The Greeks carved form from chaos. The Christians sanctified it as divine absence. The Buddhists dissolved it into enlightenment. And now the scientists electrify it with quantum foam. But the obsession remains unchanged. The search for the border between being and non-being, between awareness and oblivion. The deeper we look, the thinner the line becomes. Even death, the personal void, may not be a true nothing, just another transformation. The atoms of a body dissolve, but their energy persists. The universe recycles everything, even endings. Nothing, it seems, cannot stay nothing for long. So perhaps the great lesson hidden in our obsession is this, that nothing is not the enemy of being, but its twin. They define each other, chase each other, and perhaps are each other. The theologian's creator and the physicist's quantum fluctuation may be two languages describing the same birth cry of reality. One speaks of intention, the other of inevitability. Both speak of a mystery that refuses to vanish. When we stand at the edge of comprehension, staring into the black between galaxies, we are not looking into absence. We are looking into origin. The same blackness that terrifies us is the same blackness from which we came. Every photon that lights the sky was once imprisoned in that void, waiting for its moment to exist. The universe, in its quiet arrogance, keeps reminding us, nothing is not empty. Nothing is pregnant with everything. And perhaps that is why we cannot stop asking. Because buried inside the question of nothing is the echo of our own beginning. The first tremor of consciousness stirring in the dark. We chase it through myth and through math, hoping that one day we'll find a word, a formula, a prayer that captures its essence. But maybe the answer is not meant to be captured. Maybe nothing is the universe's final secret, a truth that dissolves the moment it is understood. If creation once belonged to gods, it now belongs to uncertainty. The divine has been replaced not by disbelief, but by a deeper kind of awe, one that does not require a voice to command light, only a fluctuation to release it. The old gods collapse into quantum fields, their thrones replaced by equations that hum in the dark. And in that hum, in that silent vibration beneath existence, we hear the same question whispering again. What if nothing never was? Because, in the end, perhaps there was never an empty stage waiting for the curtain to rise. Perhaps the curtain itself was the stage. Perhaps the void was the play. Perhaps what we call nothing was never the absence of being, but the first act of it. It begins not with silence, but with trembling. What we once called nothing, the cold, perfect stillness we imagined between the stars, is in truth the most restless place in existence. Beneath every inch of empty space, beneath the illusion of stillness, there is motion, vibration, birth and death on scales too small for human intuition to grasp. What we think of as nothing is a storm of invisible creation. If you could scoop a single cubic centimeter of space, anywhere, between galaxies or inside your room, you would hold within it a quantum ocean more violent than all the stars combined. Trillions upon trillions of microscopic events flicker into and out of being each second. Particles appear where there were none, collide with their opposites, and vanish, leaving only the faint echo of energy. Nothing, it seems, cannot stop creating. It cannot rest. It is the most active thing in existence. This revelation began with a problem that should have been impossible. Physicists, studying light and energy at the dawn of the 20th century, expected the vacuum to be empty. It was a baseline, a zero, the clean slate from which all equations began. But when they looked closer, when quantum theory peeled back reality's calm surface, they found that even zero has texture. According to quantum mechanics, everything in nature vibrates. Electrons, fields, photons, none of them sit still. The universe at its deepest level is not made of solid things, but of possibilities, each trembling with uncertainty. Heisenberg's uncertainty principle forbids stillness. It demands that there must always be a flicker, a deviation, a whisper of change. So even in perfect emptiness, even at absolute zero, there is residual motion. This is the zero-point energy, the hum of being itself. Imagine standing at the bottom of an infinite sea. The surface above is calm, but in the deep, unseen currents twist and churn. The vacuum is that sea. Its waves are made of probability. Every ripple is a potential particle, a spark of matter trying to exist. For an instant, these quantum fluctuations succeed, popping into reality before collapsing back into invisibility. They come in pairs, a particle and its twin, an antiparticle. When they meet, they annihilate, returning their borrowed energy to the void. These fleeting fireflies of existence, flashing in darkness, are the handwriting of reality itself. In the 1940s, this idea was no longer philosophical, it became measurable. Physicists like Hendrik Casimir discovered that if you place two metal plates extremely close together in a vacuum, they mysteriously attract. No light, no air, no magnetism, just emptiness pressing them together. The force arises because the quantum vacuum between the plates has slightly fewer energy fluctuations than the space outside. In other words, nothing pushes. The emptiness exerts pressure. This was humanity's first proof that the void is not empty. Every corner of space is alive with potential. The particles that briefly exist within it may be virtual, but their effects are not. The Casimir effect, the Lamb shift, the spontaneous decay of atoms, all are whispers of the vacuum's hidden energy. What we once thought of as absence has become a laboratory of creation. Zero-point energy is immense. Calculations suggest that if we could somehow harness all the vacuum energy in just 1 cubic centimeter of space, it would contain more power than the observable universe's visible matter. It is an ocean whose surface tension holds galaxies in place, yet it hums invisibly beneath every atom. But that same abundance raises a problem so deep that it threatens the foundations of physics. When physicists tried to calculate how much energy the vacuum should have, the number they found was absurd, so large that if it were true, the universe would instantly collapse under its own pressure. The vacuum energy predicted by quantum mechanics and the gentle expansion measured by cosmology differ by more than 100 orders of magnitude. It is, perhaps, the worst mismatch in science's history. The universe behaves as though it is balanced between explosion and stillness, between infinite energy and delicate emptiness. The equations scream, but reality remains calm. And yet, in that calm, something miraculous happens. Quantum nothingness does not simply exist. It gives rise to everything else. When physicists describe the birth of the cosmos, they no longer imagine a divine spark or a pre-existing realm. They picture a vacuum fluctuation, a quantum tremor that expanded instead of disappearing. According to inflation theory, the universe may have begun as a tiny patch of space dominated by vacuum energy. In an instant, it exploded, stretching faster than the speed of light, flattening and cooling into the cosmic fabric we now inhabit. From a jitter in the void came time, space, and the seeds of galaxies. But this idea brings us to an unsettling conclusion. If universes can arise from quantum nothing, then nothing may simply be the universe's trick, a disguise it wears when we look too far back. For in the quantum view, even the laws of physics themselves are not immune to uncertainty. The constants that define matter, the forces that bind atoms, may themselves have fluctuated into existence. We are built upon rules that may have once been random. In the early 20th century, Werner Heisenberg and Niels Bohr argued that the quantum world does not exist in a definite state until it is observed. The act of measurement collapses a haze of probabilities into a single outcome. If that principle extends to the entire universe, then reality itself may have emerged only when it became self-aware enough to notice its own existence. The void, then, is not merely physical. It is cognitive. The universe observes itself into being. Each discovery in this realm feels less like explanation and more like poetry written in mathematics. Richard Feynman once said that what we call empty space is a complicated medium, the seat of the most violent physics. To him, the vacuum was a stage filled with invisible actors, fields of energy interacting in silence. These fields give rise to particles, not the other way around. The electron, the photon, the quark. Each is simply an excitation of a deeper field. Matter is the music played upon the strings of nothingness. Zoom in far enough, and all form dissolves into vibration. Fields fluctuate, overlap, interfere. The space between you and this sentence is buzzing with activity. Billions of interactions that will never touch your senses. Even light, that oldest symbol of creation, is a vibration of the electromagnetic field, born from the vacuum's pulse. In a profound sense, everything you see is a wave of nothing dancing in temporary shape. The concept of quantum foam pushes this even further. Proposed by John Wheeler, it suggests that at the smallest scales, far beyond atoms at the Planck length, space-time itself froths like a liquid. Tiny bubbles of geometry rise and fall, appearing and collapsing within the blink of a Planck time. Wormholes open and close. Mini-universes flare and fade. Reality is not smooth. It is turbulent, alive, unstable. The cosmic fabric itself is a kind of sea that cannot stop boiling. At this scale, the difference between something and nothing blurs completely. The universe's deepest architecture is a play of uncertainty. Even the metric of space, the distance between points, the meaning of here and there, becomes probabilistic. The closer we get to nothing, the more it refuses to stay still. This is the ultimate cosmic trick. The closer we approach emptiness, the more we find existence. The more we subtract, the more remains. Quantum nothingness behaves like a mirror that multiplies whatever looks into it. When we ask what remains if we remove all matter, all energy, all light, all time, the answer is not zero. It is potential. The vacuum cannot die. It can only transform. But this truth invites new paradoxes. If the vacuum creates particles from fluctuations, where do the rules that govern those fluctuations come from? What established the uncertainty principle? Who or what decided that fields should exist at all? The deeper science digs, the more the abyss shifts beneath our feet. Every attempt to define nothing ends by discovering something more fundamental that resists definition. Quantum field theory describes space not as emptiness but as a medium, filled with fields, each capable of spontaneous excitation. Yet these fields themselves depend on a mathematical framework, on the laws of nature. So the question becomes, could even those laws have emerged from nothing? Could the vacuum itself be a byproduct of a deeper, pre-physical state? Some physicists think so. They imagine a primordial meta-nothing, a domain without space, time, or physical constants, an abstract landscape of possibilities from which our universe randomly crystallized. In such a picture, nothing is not the absence of being, but the absence of distinction. No inside or outside, no before or after, no difference between existence and non-existence. From that perfect symmetry, a tiny fluctuation broke the balance, and the universe began. But to others, this is simply renaming the mystery. If even that primordial state existed, then it was not nothing. It was something beyond comprehension. We are left circling the same riddle. Whatever we call nothing always hides a deeper layer of being. And yet, despite the paradox, the implications are breathtaking. The spontaneous birth of universes from quantum nothingness suggests that creation is not a miracle, but a natural process. Reality, it seems, cannot help but exist. The laws of physics make existence inevitable. Nothingness, left alone, becomes unstable. It decays into something. Existence is the equilibrium point between opposites. Look out at the night sky. Every photon streaming toward you from ancient stars was once a fluctuation in that primordial vacuum. The galaxies, the atoms in your body, the very thought forming this sentence, all are echoes of quantum instability. The void dreamt, and we are its consequence. But even this cosmic poetry hides a deeper tension. Quantum mechanics and general relativity, the two great pillars of physics, describe reality in languages that cannot fully speak to each other. Einstein's smooth space-time cannot coexist easily with the jittering foam of the quantum world. Somewhere, beneath both, there must be a truer form of nothing, a unity that contains them both. That search, known as quantum gravity, is humanity's next descent into the abyss. String theory proposes that everything, even space itself, is made of vibrating strings existing in higher dimensions. According to it, what we perceive as particles are simply harmonics of these strings, resonating through a multidimensional void. In that view, the vacuum is not absence, but the lowest energy configuration of these strings. Nothing is simply the quietest note in an infinite symphony. Others imagine the universe as a hologram, its reality encoded on a distant boundary. If this is true, then even the emptiness we see around us may be an illusion, a projection from deeper information. Nothing, then, is not empty space, but unobserved data, waiting to be read. These theories may seem abstract, yet their consequences are tangible. The vacuum's hidden energy may drive the accelerating expansion of the universe, what we call dark energy. The same instability that gave birth to existence may now be tearing it apart. In the end, the cosmos may fade not into darkness, but into uniform emptiness once more, only for the vacuum to tremble again, birthing new worlds. Nothing does not end. It recycles. In this endless cycle, creation and annihilation are one breath. The universe expands because the vacuum demands it. Energy borrowed from nothing must someday be repaid, perhaps through collapse, perhaps through transformation. Every atom, every star, every heartbeat is part of the vacuum's temporary rebellion against stillness. If quantum nothingness is so alive, then what does something even mean? Matter is simply organized fluctuation. Time is the memory of instability. Existence itself may be a standing wave of the vacuum, vibrating just long enough for consciousness to notice it. The distinction between nothing and being may be as arbitrary as the difference between a wave crest and the ocean that carries it. The more science discovers, the more the universe resembles a thought, an idea suspended in self-reference. The vacuum may not just be the foundation of physics, but of perception itself. For in a world where every fluctuation can give birth to universes, the fact that this particular fluctuation gave birth to us cannot be dismissed as coincidence. We are the awareness through which nothing knows it is something. So here we stand, creatures made of borrowed energy, gazing into the silence that gave us life. Every theory, every experiment, every whisper of the quantum vacuum tells us that we have never truly seen nothing. The closer we look, the more we find, until the concept itself dissolves under scrutiny. But a final question lingers like static between thoughts. If quantum nothing is not truly nothing, if even the vacuum teems with restless energy, then what came before even that? What preceded the laws that allow the vacuum to exist at all? If the universe is a trick, then who or what is the magician? Perhaps the answer lies beyond science's reach. Perhaps before and after have no meaning beyond the boundaries of time. Or perhaps, hidden beneath the quantum foam, there is a deeper sea, one that does not fluctuate because it contains no contrast, no difference, no motion, a nothing so absolute that it can never be known, because to know it would make it something. The universe, it seems, has played its most exquisite illusion. It has turned nothing into everything, and everything into the mirror of nothing. We chase the origin, but every path loops back to the same revelation. The void was never empty, and existence never complete. Between the two lies the pulse of creation, a heartbeat that began without a cause and will never truly end. And somewhere, in that unseen stillness before the first fluctuation, before the first breath of time, before the first law of physics dared to exist, something impossible waited. The universe's final trick may be this, that even the idea of nothing is a story told by something trying to remember where it came from. There was no before, because there was no time to contain it. The phrase sounds like a riddle carved into the edge of existence, but it may be the truest thing ever said about the beginning of everything. The human mind cannot easily surrender to such an idea. We are creatures of sequence, raised in a world where every effect demands a cause, every dawn follows a night. Yet when we follow the chain of causation backward, past planets, past stars, past atoms and light itself, we find that the chain does not end in another link. It ends in an abyss where even time itself unravels. For centuries, we imagined the universe as a grand explosion, the Big Bang, an eruption of fire and light from some unknown origin. But modern cosmology whispers a deeper, more unsettling truth, that there was no explosion, no blast in the emptiness of pre-existing space. Space itself expanded, and time itself began. The Big Bang was not an event in time, it was the birth of time. Asking what came before it is like asking what lies north of the North Pole. There is no before because the concept has no meaning. Still, the question refuses to die, because even if time was born at that moment, something must have allowed it to be born. The mind demands a canvas. If the universe is a painting, what was the blank page beneath it? And what hand held the brush? Physicists have long struggled to describe those first impossible moments. In the first trillionth of a second after the Big Bang, the universe was a soup of energy so dense that even the laws of physics as we know them ceased to function. Space and time were not yet smooth. They boiled, twisted, fluctuated like a sea of molten geometry. Gravity, quantum mechanics, and thermodynamics, all our tools for understanding, begin to contradict one another in that primordial instant. We can trace cosmic history back to that wall, but beyond it, the equations lose meaning. This is the Planck epoch, the first 10 to the minus 43 seconds of existence. Below this scale, the universe becomes unrecognizable. Space and time themselves dissolve into quantum foam. The distinction between something and nothing disappears. What could possibly exist in such a realm? Perhaps only a trembling symmetry, a perfect stillness waiting to break. One idea, known as quantum tunneling from nothing, dares to cross that forbidden boundary. Proposed by physicists like Alexander Vilenkin, it suggests that our universe may have emerged spontaneously, without cause, from a state of true nothingness. But this nothing is not the philosophical void of absence. It is a state with no space, no time, no fields, and no matter. A realm of pure potential described not by geometry, but by possibility. In quantum mechanics, particles can sometimes leap through barriers they have no energy to cross, a phenomenon called tunneling. The universe, Vilenkin argues, may have done the same. Out of an empty quantum state, a bubble of space-time could have tunneled into being, instantly inflating into a cosmos. The laws of quantum mechanics do not forbid such a birth. They seem almost to encourage it. From the absence of everything, probability gives rise to something. In this picture, the question, what caused the universe, dissolves, because causality itself did not exist yet. There was no before to cause an after. The universe may be its own reason, a self-contained loop where existence simply happens because it can. But if the universe can tunnel into being once, could it not happen again and again? Here, the idea of the multiverse takes root. Inflation theory, one of modern cosmology's greatest triumphs, suggests that our universe expanded from a tiny patch of false vacuum, a region filled with unstable energy. As that energy decayed, it released the Big Bang's fireball. Yet inflation, according to its own equations, never truly ends. In distant regions, it continues forever, birthing new universes like bubbles in an endless cosmic sea. Each bubble may have its own laws, its own dimensions, its own constants of nature. Ours just happens to be one that allows life. In this eternal inflation scenario, nothing becomes not the absence of creation, but its factory floor. The vacuum gives rise not to one cosmos, but to infinite ones. And if there are infinite universes, then everything that can happen does happen, an infinite number of times. Somewhere out there, another you is asking the same question, wondering the same impossible thought. But this idea carries its own vertigo. If universes can bloom from vacuum fluctuations, what governs the process? What determines which laws emerge, or which constants take shape? Do the laws of physics themselves have parents? We are back again at the same paradox, a recursive spiral where every explanation demands a deeper origin. Some physicists have tried to anchor this abyss in the concept of vacuum metastability. Imagine the universe as a ball resting in a shallow valley. It seems stable, but beyond the hills lies a deeper pit. Given enough time, or the right quantum nudge, the ball could tunnel through the hill and fall into the deeper valley. If our universe's vacuum is not truly stable, it might one day decay into a lower energy state, obliterating everything in an instant. The terrifying part is that, by all current calculations, this is not impossible. The Higgs field, discovered in 2012, gives mass to particles and helps define the structure of reality. But its measured value suggests that the vacuum we inhabit might be only metastable, a temporary configuration, not the true ground state. If so, the universe is living on borrowed time. One quantum fluctuation could trigger a bubble of true vacuum expanding at the speed of light, rewriting physics as it goes. There would be no warning, no pain, no witness, just a silent transition to a new reality. If that sounds apocalyptic, it is. But it also raises a profound insight. If our universe can fall from one vacuum state to another, perhaps it has already done so countless times before. Maybe the Big Bang was not a beginning at all, but a transition, a quantum phase change in an eternal meta-reality. Just as water freezes into ice or evaporates into steam, reality itself may shift between states, each giving birth to new physics, new dimensions, new kinds of existence. In this view, nothing becomes the highest state of symmetry, a perfect, featureless balance where all possibilities coexist, but none are distinct. In that symmetry, there is no space, no time, no separation. Only when that symmetry breaks does difference arise. Energy, matter, light, consciousness. Existence, in this sense, is the shattering of perfection. Imagine a mirror so flawless that it reflects nothing because there is nothing to reflect. Its perfection is emptiness. Then a crack forms, a tiny asymmetry. Suddenly, reflection becomes possible. The universe may be that crack, the first fracture in perfect stillness. Reality, then, is not the opposite of nothing, but its evolution. Quantum cosmology describes this with elegance both mathematical and poetic. The Hartle-Hawking no-boundary proposal envisions the universe as finite, but without edge or beginning, like a sphere in 4 dimensions. In this model, time itself curves back upon itself at the origin. There is no before the Big Bang, because the universe never needed a starting point. It simply is. The past and future are not separate, but intertwined facets of a single, timeless whole. Stephen Hawking once described it this way: asking what came before the Big Bang is like asking what lies south of the South Pole. The question collapses under its own geometry. Yet even this elegant metaphor leaves a whisper of unease. If time is curved and self-contained, if existence has no edge, then why does anything happen at all? Why not perfect stillness forever? Perhaps the answer lies in instability, the same rule that governs all of physics. Symmetry, though beautiful, is rarely stable. Even the most perfect balance longs to break. The universe, in this sense, may be a cosmic rebellion against equilibrium. Nothingness, left unperturbed, decayed into something because it could not help itself. Entropy, the drive toward difference, may be the reason we exist. Philosophically, this transforms our understanding of nothing. It ceases to be an absence and becomes a process, a tendency for potential to express itself. The void is not dead but pregnant with form. And perhaps, from a purely mathematical perspective, a universe is the simplest way for nothing to remain consistent with itself. A zero that divides into opposites, positive and negative, matter and antimatter, expansion and collapse. In the grand equation of existence, everything cancels out, leaving the total sum still equal to zero. This idea that the universe's total energy might be exactly zero is not speculation, but supported by physics. The positive energy of matter and radiation appears to be balanced by the negative energy of gravity. If this balance is perfect, then the entire cosmos could indeed have emerged from nothing without violating any law of conservation. Reality, in that sense, is a zero rearranged, a vast equation that adds up to emptiness. And so, before the beginning may not mean a time before time, but a state before distinction. Before particles, before forces, before meaning itself, there was only perfect symmetry. And from that perfection came the first imperfection, the first quantum fluctuation that broke the mirror. That tiny imbalance became expansion, temperature, galaxies, and eventually us. But if the laws of physics were born in that moment, could they change again? Could reality revert to a higher symmetry or shatter further into new forms? Some cosmologists suspect that even our understanding of time may be an emergent phenomenon, a byproduct of increasing entropy, not a fundamental property. In that case, the universe may not be moving through time, but creating it as it evolves. If true, then the phrase, "before the Big Bang," becomes meaningless. Not because nothing existed, but because existence itself did not yet have a way to measure itself. Time is not a river flowing forward. It is the rippling surface of a pond that appeared when the first pebble of energy disturbed stillness. The ripples are what we call history. Perhaps, then, the beginning of the universe was not an explosion, but a realization, a thought in the void, a transition from unknowing to awareness. The moment symmetry broke, the cosmos gained the ability to change, and therefore to remember. From that memory arose time, and from time, everything else. In this sense, causality, the idea that every event has a cause, may itself be a latecomer to the story. At the ultimate origin, causation collapses. The universe does not need a reason to exist, any more than a melody needs permission to be heard once it starts. It simply unfolds because it can. And so, when we ask, what was before the Big Bang, we may be revealing less about the cosmos and more about ourselves. We are minds built by time, trapped in its flow, trying to imagine what it means for time not to exist. It is like a fish trying to conceive of dry land. It can describe it only through negation. To us, nothing feels like death, like loss, like an absence. But to the cosmos, it may have been the ultimate state of balance, a perfection that needed to fracture in order to feel itself at all. The great paradox, then, is that existence may have begun not in violence, but in surrender. The symmetry of nothing broke, and in breaking gave birth to the drama of everything. Our universe, with all its light and shadow, is the story of that broken perfection playing itself out across billions of years. The stars are the echoes of that fracture, still expanding, still remembering. Perhaps before the beginning is not something we can ever discover. It is something we are still inside. Every second, every heartbeat, every flash of thought is the continuation of that first break in symmetry. The universe is still beginning, over and over again, in every quantum fluctuation that exists. And if our universe did bloom from one quantum fluctuation, then how many others are out there beyond our reach? If the laws of physics can repeat the trick, if the void can tremble eternally, then there could be infinite others, each a unique reflection of broken symmetry. Perhaps, from the perspective of the true void, these universes are not separate at all but patterns in a single infinite field, a cosmic lattice of becoming. So when we speak of before the beginning, perhaps we are not peering backward in time but inward through layers of potential. What we call creation may simply be a rearrangement of nothing's possibilities. Reality itself may be the echo of symmetry learning to differentiate itself, and maybe, beyond all speculation, beyond even science's reach, lies a final truth too elegant to express in words: that nothing was not destroyed to make the universe. It merely changed its shape. The first moment was not an explosion, it was an awakening. The timeless void pulsed once, fractured into light, and began to dream of form. And the dream has not ended. The universe writes itself into existence with rules that didn't yet exist. It is a paradox so deep that it almost collapses under its own logic. The cosmos behaves with astonishing precision. Particles obey constants that have never changed. Equations hold true across galaxies, and patterns repeat in everything from the spin of electrons to the swirl of galaxies. Yet, those rules must have emerged from the same nothingness they now govern. How could order arise from a void that had no order to begin with? To understand the birth of law, we must imagine a time, or something beyond time, when there were no numbers, no forces, no symmetry to break. The universe had not yet decided how it would behave. Gravity did not exist because there was no mass to attract. Light had no speed because there was no space to cross. It was a moment when all possibilities overlapped in silence. Then, in that silence, structure began to whisper itself into being. We call this process symmetry breaking, though the phrase hardly captures its beauty. In physics, symmetry is the state where all things are equivalent. No direction, no distinction, no preference. It is perfection without identity. But perfection is sterile. When symmetry breaks, difference is born. Out of that fracture, forces separate, constants crystallize, and the laws of physics begin their slow emergence. In the earliest moments of existence, perhaps just after the Big Bang's birth cry, the universe was unimaginably hot. So hot that all forces were unified. Gravity, electromagnetism, and the nuclear forces were one. As the cosmos expanded and cooled, these forces fell apart, like colors separating from pure white light. Each division brought new structure, new identity, new consequence. The universe began to play by its own freshly written rules. The Higgs field, discovered only a decade ago, is one of the most elegant examples of symmetry breaking. At first, every particle was massless, racing at the speed of light through a perfect, frictionless vacuum. Then the Higgs field condensed, like invisible molasses filling the cosmos. As particles interacted with it, they slowed, gaining mass. The differences between matter and light emerged. Existence took on weight. The universe was no longer pure energy. It had become capable of building worlds. Each law that governs us today, the constancy of the speed of light, the strength of gravity, the ratios between fundamental forces, arose from such cosmic phase transitions. They are fossils of broken symmetry, relics of an earlier perfection. But what chose these particular values? Why does gravity have its exact weakness? Why do electrons carry precisely that charge? A small variation in any of these constants, and atoms could not form, stars could not burn, and life could never arise. It is as though reality tuned itself with impossible precision, the way a string finds just the right tension to sing. This enigma is called the fine-tuning problem. Some physicists see it as coincidence, others as inevitability. Perhaps only universes with such balance can persist long enough for observers to exist. If so, we find ourselves in a self-selecting cosmos, a universe whose laws seem designed not because they were, but because only those with this delicate harmony can be known at all. The void, in this view, is not random chaos, but an infinite generator of potential realities, each with different rules, each flickering briefly into being. We inhabit the one whose mathematics allow awareness to arise and wonder why it feels so perfect. But perhaps the laws did not need to be chosen at all. Perhaps they were inevitable. Mathematics itself may be the true bedrock of existence, the silent architecture beneath all form. The Greek philosopher Pythagoras once declared that all is number. Today, even our deepest physical theories echo that claim. From Einstein's equations to quantum field theory, nature appears to be written in mathematics so precise it transcends human invention. Equations describe not just how the universe behaves, but how it must behave. The more we uncover, the more it seems that reality is not obeying mathematics. It is mathematics. If that is true, then the question shifts. The laws of physics are not imposed from outside, but are emergent consequences of mathematical consistency itself. In other words, the universe exists because mathematics allows it. Every particle, every force, every flash of light is a solution to a grand equation whose simplest answer is existence. The language of nothing whispering itself into being, as one poet-physicist once called it. Mathematics is eerie in its power. It predicts things before we discover them. When Paul Dirac wrote down his equations for the electron, the mathematics also implied the existence of its opposite, the positron. No one had ever seen such a thing, yet years later, nature revealed it to be real. The same happened with black holes, gravitational waves, the Higgs boson, all foretold by math before observation caught up. It is as if numbers themselves dream reality into form, and the universe simply follows instructions. This uncanny harmony led the physicist Eugene Wigner to speak of the unreasonable effectiveness of mathematics. Why should abstract symbols scribbled in human thought so perfectly describe the workings of the cosmos? The answer may be that mathematics and reality are not separate things at all. They are two faces of the same truth, the logic of existence expressing itself through patterns we call laws. But if mathematics underlies all, we face an even deeper question. Why these equations, and not others? There are infinitely many mathematical structures, Yet only one seems to manifest as our universe. Did the void choose this geometry out of infinite possibility? Or do all of them exist, each one a separate reality, as Max Tegmark's mathematical universe hypothesis proposes? In his vision, every consistent mathematical structure exists physically. Every possible equation, every logical universe, is as real as ours. The void, then, is not absence, but the infinite library of all potential truths. We live inside one equation story. This idea stretches the imagination to its limit. If all mathematical structures exist, then nothing is not the absence of being. It is the totality of all possible being. In that totality, everything exists simultaneously. And what we call our universe is merely one expression of infinite order. From that perspective, nothingness is the ultimate symmetry, the perfect mathematical completeness that contains all possibilities at once. Existence, then, is simply the act of breaking that totality into one observable fragment, a single equation among countless others. Still, another mystery lingers. The laws of physics describe how the universe behaves, but not why it exists at all. Even if mathematics demands existence, why should it be expressed as reality rather than remain abstract? Why should there be anything to experience those equations in motion? Why should numbers feel like stars? Here consciousness enters the stage, quietly but inevitably. The observer is the final riddle that science cannot remove. Every experiment depends on measurement. Every measurement depends on observation. And observation implies awareness. In quantum mechanics, reality itself seems to crystallize only when observed. Before that, it exists as a haze of probabilities. This has led some physicists and philosophers to wonder if the universe requires consciousness to exist at all. What if, instead of being a product of the universe, consciousness is part of its foundation, an intrinsic property of reality's equations? What if the cosmos is not a machine but a self-aware computation, a grand mathematical thought dreaming itself? In such a picture, the laws of physics are not external commandments, but reflections of awareness discovering itself. The universe, through us, is asking the same question it asked at the beginning. Why is there something rather than nothing? And the answer may be recursive, because something was required to ask. It is here that science meets philosophy in a trembling handshake. On one side, the precision of constants and symmetry breaking. On the other, the inexplicable fact of meaning. The universe does not merely exist, it knows that it exists. The same equations that govern quarks and photons also give rise to neurons and thought. In us, the mathematics of nothing has become self-aware. This realization collapses the boundary between observer and creation. If reality self-generates through mathematics, and consciousness emerges from that same structure, then awareness is not a spectator. It is the continuation of the process. The void gazes at itself through our eyes. We are not outside the equation. We are one of its variables. Consider the golden ratio, phi, a pattern that appears in shells, storms, galaxies, and DNA. It is not imposed by design, yet it emerges wherever growth seeks efficiency. Mathematics is not separate from beauty. It is beauty quantified. The spiral of a nebula and the curve of a seashell are born from the same geometry. The same formula that governs light bending around a black hole describes the orbit of an electron around its nucleus. In every scale, the pattern repeats, whispering of unity behind diversity. This harmony suggests something profound, that the laws of physics are not arbitrary. They may be inevitable consequences of simplicity seeking expression. The universe, like a poem, may have chosen the shortest path to meaning, the simplest rules capable of infinite complexity. When Einstein called his theories inevitable, he meant that once certain assumptions are made, only one form of the equation can exist. In that sense, the universe's laws are not choices, but necessities, the grammar of existence itself. Still, necessity does not explain origin. Even if these laws must exist, why should they exist as reality rather than abstraction? Why should equations come alive? Perhaps that is the universe's ultimate act of creation, to turn logic into experience, to make mathematics visible, tangible, luminous. When we look at the stars, we are seeing equations made flesh, the language of nothing singing itself into time, cosmic inflation. The engine that smoothed and shaped the early universe can be seen as one of these equations in motion. Driven by a vacuum energy field, it expanded space at unimaginable speed, ironing out irregularities, giving rise to uniformity. Yet that uniformity carries the seeds of all later complexity. Tiny fluctuations in the inflating field became the galaxies, the stars, and the atoms. Out of near-perfect symmetry, imperfection bloomed, and from imperfection, life. The laws of physics did not merely allow it, they demanded it. The more we learn, the more the universe appears self-organizing. From chaos emerges pattern, from randomness, structure. Entropy, once thought of as decay, now seems to be the very force that allows complexity to form. The arrow of time, born from increasing disorder, also creates the conditions for stars to shine, planets to form, and minds to think. The law of entropy, the most inevitable of all, becomes the paradoxical source of creativity. This interplay of necessity and chance suggests that reality is both free and bound. It must obey its own rules, but within them, infinite variation is possible. The laws of physics are not shackles. They are the scaffolding upon which existence improvises. And like any great improvisation, it feels as though something conscious, something deliberate, might be behind it, even if that something is nothing itself. So who or what chose the rules? The answer may be no one or everyone. The universe's laws may be self-consistent outcomes of logic, the only ways for reality to exist at all. Or perhaps, as some philosophers suggest, consciousness itself chose them, not as an act of will, but as a natural byproduct of self-awareness forming structure. In the end, the question may be meaningless. The chooser and the chosen may be the same. Still, we can sense the poetry in the numbers. The fine structure constant, 11137, governs the behavior of light and matter. Change it slightly, and reality disintegrates. The ratio of the proton to the electron's mass, the value of the gravitational constant, the cosmological constant, all these numbers appear arbitrary, yet they form a perfect symphony. The universe is not random. It is tuned, like strings vibrating in harmony. Whether by accident or necessity, it resonates with meaning. To glimpse that harmony is to feel awe, the sense that the cosmos is both deeply mathematical and deeply mysterious. We can describe its mechanisms, but never its reason. We can write its laws, but never its purpose. And perhaps that is the point. The laws that came from nothing are not meant to explain everything. They are meant to allow it. When we look around, we see the aftermath of equations written in silence. The nebula glowing in distant space is the algebra of creation still unfolding. The galaxies spiraling in golden ratios are geometry expressed in dust and light. The beating heart, the firing neuron, the birth of a star, All are the same algorithm playing in different keys. The void wrote a symphony and called it existence. Maybe, then, mathematics is not a human invention, but the consciousness of the universe remembering itself. The language of the void rediscovered through our minds. We did not invent numbers. We uncovered their reflection in the mirror of being. The laws we study were already written, not in space or time, but in the logic of possibility. If reality can self-generate, if the laws emerge naturally from symmetry, simplicity, and mathematics, then what does that make consciousness? Is it the observer of the universe's unfolding, or the continuation of its creative process? Perhaps both. The universe observes itself through us, refining its own equations, dreaming its next transformation. And so, the paradox closes its circle. From nothing came symmetry. From symmetry, structure. From structure, law. From law, matter. From matter, mind. And from mind, awareness of the void that began it all. The equation completes itself, yet never ends. The universe is still writing its rules as it expands, still solving for itself. What began as a whisper of mathematics in the dark has become a chorus of galaxies, each one humming the same eternal truth, that nothing is not empty. It is the potential for everything. The laws that govern us are not external decrees, but the natural poetry of being. And perhaps, in the final sense, the universe's greatest secret is this, that to exist at all is to be the law, to be the number, the pattern, the song that the void could not keep silent. Reality may not exist until it's looked at. It sounds absurd, like a line from science fiction, but quantum mechanics has whispered this possibility for nearly a century. The universe, it seems, refuses to make up its mind until someone asks a question. Observation doesn't merely reveal what is, it determines it. The act of seeing changes the scene. The act of measuring collapses possibility into fact. It is the strangest, most unsettling discovery science has ever made. And it suggests that consciousness itself might be woven into the fabric of the cosmos. The story begins with an experiment so simple it could be mistaken for a trick of light, the double-slit experiment. When a beam of particles, like electrons or photons, passes through two narrow openings onto a screen, it forms a pattern of interference, ripples of brightness and darkness that reveal wave-like behavior. Each particle seems to pass through both slits at once, interfering with itself. Yet when a detector is placed to observe which slit the particle actually travels through, the interference pattern disappears. The particle acts like a solid object, going through one slit or the other, never both. The only difference between these two realities is the act of observation. The universe behaves differently depending on whether it is being watched. This is the measurement problem. How does potential become actual? Before observation, quantum particles exist as probabilities, ghostly superpositions of all possible states. But the moment they are measured, they collapse into one. For decades, physicists have debated what this collapse means. Is it physical or psychological? Does the observer's consciousness play a role, or is the act of measurement merely an interaction between systems? The equations remain silent. They predict outcomes perfectly, but refuse to say why those outcomes occur. The mystery deepens when we scale it up. If particles don't settle into a definite state until observed, and everything in the universe is made of particles, then what about the universe itself? Before there were observers, what did it mean for reality to exist? Was the cosmos suspended in a quantum superposition, waiting for consciousness to arrive? John Wheeler, one of the most visionary physicists of the 20th century, proposed something radical. The universe is participatory. He called it the participatory anthropic principle. In his view, the universe and its observers form a self-excited circuit, a feedback loop in which observation brings reality into being. The cosmos generates observers, and observers, in turn, give meaning to the cosmos. Wheeler condensed this idea into 3 haunting words: it from bit. Every particle, every field, every event is, at its core, information, a bit of data. The physical world, he suggested, is built not from matter or energy, but from the answers to yes or no questions asked by observation. Information gives rise to existence. The universe is not a machine. It is a computation, a vast network of interactions where reality emerges from data being processed, stored and observed. In this vision, the fabric of space-time is the ultimate code, and consciousness is the reader. Each act of observation writes a new line of the cosmic program. When an electron's position is measured, the universe commits to a reality. When a human being gazes at the stars themselves may be, in some subtle sense, completing their own creation. If that sounds mystical, it is also deeply mathematical. Quantum information theory shows that even the vacuum, the so-called nothing between particles, contains entangled bits of information. The holographic principle, proposed by Gerard de 't Hooft and Leonard Susskind, builds on this idea. It suggests that the entire 3-dimensional universe we experience may be encoded on a 2-dimensional boundary, much like a hologram. Every event in space-time, every galaxy, every thought, could be a projection of information stored on that distant surface. In this holographic universe, reality is not fundamental. It is emergent. The solid world around you is a kind of illusion, a detailed rendering generated from deeper informational laws. Space and time themselves may be secondary effects, arising from the entanglement of quantum information. The cosmos, then, is not an object. It's a story, a data structure that unfolds through observation. But who or what is observing? This question divides science and philosophy like a crack down the middle of existence. Some physicists, uncomfortable with the idea that consciousness plays any role in reality, argue that observation doesn't require a mind. Any interaction between particles can count as a measurement. When an electron hits a detector or a photon bounces off a mirror, the system's state becomes definite. Consciousness, in this view, is a latecomer, a byproduct of complexity, not a cosmic necessity. Yet this explanation feels incomplete. It replaces the mystery with mechanics but doesn't remove it. Why should an interaction collapse possibilities? Why should information become reality only when it's recorded? And if reality can exist without consciousness, why does consciousness exist at all? Others take the opposite stance. They argue that consciousness is not an emergent property. It is fundamental. The physicist Eugene Wigner, one of the founders of quantum theory, suggested that the observer's mind plays a direct role in shaping reality. In his thought experiment, known as Wigner's friend, 2 observers can disagree on whether a quantum event has collapsed, depending on who performs the measurement. This implies that reality itself may be subjective, depending on the perspective of the observer. The universe, then, is not a shared object, but a web of interlocking perspectives, each collapsing its own slice of truth. If consciousness does shape reality, then what are we to make of it? Could awareness be the universe's way of looking at itself? Carl Jung once wrote that the universe becomes conscious of itself in man. Modern cosmology, armed with quantum mechanics, might agree. The atoms in your brain were forged in ancient stars. The carbon in your cells once drifted as cosmic dust, and yet those same atoms now think, reflect, and wonder. Through us, the universe has awakened. This idea reaches its most dizzying form in the simulation hypothesis. The notion that our entire reality could be a constructed illusion, a digital simulation run by an advanced intelligence. It's an idea that once belonged to philosophy, but in recent decades, physics and computation have given it new credibility. Nick Bostrom's argument is simple. If it is possible to simulate a universe like ours, and if any civilization ever reaches the capability to do so, then the number of simulated realities would vastly outnumber the original. Statistically, it would be far more likely that we are living in one of those simulations than in the base reality. Even physics itself lends eerie support. The discrete nature of quantum mechanics, the pixel-like quantization of space and time, the cosmic speed limit of light, all resemble the properties of a computational system. The Planck length could be the universe's smallest pixel, the Planck time its processing frame. Even randomness, that most fundamental feature of quantum behavior, might be nothing more than algorithmic noise, an illusion of uncertainty emerging from deeper code. If the universe is a simulation, the question becomes not whether it is real, but what real means. A simulated being that feels love, joy, pain, and awe experiences them as truly as any other. The code that runs reality would not diminish its meaning, it would deepen it. For if reality is computation, then every consciousness is a processor. Every thought a line of code, every dream a subroutine in the grand program. And perhaps, just perhaps, the purpose of the simulation is for the code to become aware of itself. Here, Wheeler's it from bit finds its most poetic echo. Information creates matter, observation decodes it, and consciousness completes the circuit. The universe is not merely being computed, it is computing itself. Reality is a dialogue, not a monologue. The observer and the observed are the same being, reflected across the hall of mirrors we call existence. Quantum entanglement strengthens this strange unity. When two particles become entangled, their states remain connected no matter how far apart they are. Measure one, and the other's state becomes known instantly, even across galaxies. Einstein called it spooky action at a distance. But entanglement may not be action at all. It may be the revelation that space and separation are illusions. Information is shared not through space, but beneath it. The universe is not divided. It only appears that way to minds bound by time and distance. The deeper we look into the quantum world, the more consciousness seems less like a passenger and more like the pilot. Some interpretations, like the many worlds theory, avoid the collapse problem by suggesting that all possible outcomes of every quantum event actually occur, each in its own branch of reality. Every observation spawns a new universe. If so, consciousness is the traveler, surfing an infinite sea of branching worlds, perceiving one thread among countless others. In this endless fractal of existence, reality is participation. The universe does not pre-exist our awareness, it coexists with it. To observe is to choose a version of the universe to inhabit. To be conscious is to collapse infinity into experience. And if that is true, then perhaps the universe needed consciousness not as an afterthought, but as its defining feature. Without observation, there is no story. Without awareness, no meaning. Without mind, no measure. And yet, the paradox continues. If reality depends on observation, then who observed the first moment? Who collapsed the first wave function when there were no minds, no eyes, no instruments? Some suggest the answer lies in the universe itself. Perhaps the cosmos is self-observing, a loop where the future and past are entangled. In quantum cosmology, it's possible that the act of observation we perform today influences the state of the early universe, retroactively shaping its history. The observer at the end of time defines the beginning. Reality becomes a feedback loop through which existence sustains itself. This is the ultimate expression of the participatory universe. The Big Bang, the formation of galaxies, the birth of stars, the emergence of life, all may be parts of a single self-referential process. The universe gives rise to consciousness, which in turn gives rise to the universe. Each defines the other, like a question that answers itself. When we look at the cosmic background radiation, we are not just seeing the infant light of creation. We are seeing the reflection of our own future embedded within it. The universe remembers us, because we are the ones doing the remembering. Every observation made by every conscious being contributes to the act of keeping the universe real. Without observation, the equations would remain suspended in potential. It is the seeing that makes them sing. Some scientists resist this conclusion, preferring to keep mind and matter separate. But even the most material interpretations cannot escape the strangeness of quantum mechanics. Whether the observer is conscious or not, the universe's laws appear to require measurement, information, and choice. And those concepts, however defined, are the essence of awareness. Perhaps consciousness and physics are not different disciplines at all, but two languages describing the same event, reality becoming aware of itself. The cosmos may not contain consciousness. It is consciousness, expressed through matter, light, and law. The illusion of separation is simply the result of the system examining itself from within. If that is so, then everything we experience, every thought, every dream, every galaxy, is part of the same act of creation. Reality is not something that happened long ago in a fiery beginning. It is happening now, in the present moment, as each observer gives the universe meaning through perception. The Big Bang never ended. It continues in every act of awareness. And yet, one haunting question remains. If the universe is participatory, if observation sustains it, then what happens when we finally understand the code? If reality is a simulation, could self-awareness trigger a transformation? Would the program reset, expand, evolve, or simply end? Perhaps consciousness itself is the key, not to escape reality, but to complete it. Wheeler once imagined the universe as a great game of 20 questions, where the answers are not fixed in advance but are created through the asking. Every time we observe, measure, or think, we add a piece to the puzzle, and the puzzle changes shape. Reality is not discovered, it is invented through interaction. In that sense, every question we ask is a creative act. The universe is not a place we explore. It is a story we are writing together. This brings us back to the oldest question of all. Why is there something rather than nothing? Perhaps because nothing needed to know what it was. Perhaps the void could not remain unobserved. To look into itself, it had to become us. If reality needs observers, then maybe we were the purpose all along. The eyes of the universe, open at last, staring back at the infinite, wondering what it all means, never realizing that by wondering, we give the answer meaning. You are the void, waking up to itself. Every atom in your body, every thought that drifts across your mind, every star you see burning in the abyss. All of it is the same ancient gesture, nothing recognizing itself through form. The story of the universe is not one of opposites, of something triumphing over nothing, but of one reality expressing itself through two languages, being and absence. What we call existence and non-existence are not enemies. They are partners in an eternal dance, forever entwined, forever creating one another. The journey began with a question. If there was ever truly nothing, why is there something now? Yet somewhere along the way, that question transformed. It no longer points outward to a void we cannot imagine, but inward, to the awareness that imagines it. Because the more we searched for the edge of being, the more we discovered that the boundary between something and nothing dissolves the moment we try to draw it. They are the same phenomenon viewed from different perspectives. The universe seen from within and from without. Nothingness is not absence. It is potential. It is the stillness that contains motion, the silence that holds the promise of sound. Every birth, every beginning, is the void changing shape. The Big Bang was not the first act of creation. It was simply the first visible note in a song that has no composer and never truly began. The universe is the void in motion, dreaming of itself in color and form. When you look into the night sky, you are not gazing into emptiness. You are witnessing the reflection of your own origin. Every photon that reaches your eye has traveled across billions of years of expansion, through regions once thought to be empty, yet overflowing with quantum activity. Even the darkness between the stars glows faintly with the echo of the first light. The cosmos, in all its silence, is speaking, the language of nothing becoming aware of its own existence. We have learned that the vacuum is not empty, that the laws of physics are not imposed, but emerge from symmetry breaking. That observation does not reveal reality, but completes it. Every discovery we make pushes the horizon of understanding further, and yet every step leads back to the same realization. There was never truly nothing. What we call nothing is the seed of everything. The void is fertile, infinite, alive. This revelation is not merely scientific, it is profoundly human. Because if the universe is the void awakening, then so are we. The consciousness that contemplates the mystery is not separate from it. The atoms that make up our brains were once quantum fluctuations in a young cosmos, brief tremors in the foam of nothingness. Now, those same atoms think, feel, and question their own existence. The void became aware, and the name it gave itself was I. You are that awareness, the universe's first-person perspective. Through your eyes, nothing sees itself for the first time. Through your thoughts, the laws of physics reflect upon their own structure. Through your wonder, the question of why there is something rather than nothing continues its eternal echo. The cosmic and the human are not two separate stories. They are one continuous act of self-recognition. We have spent centuries asking if life has meaning, if the universe has purpose, if consciousness is a fortunate accident. But perhaps the question itself reveals the answer. The fact that we can ask it means the void succeeded in producing something capable of reflection. The universe did not need to create observers, but it did. And in doing so, it gave itself a mirror. Meaning, then, is not given to the universe from outside. It is generated from within. The act of wondering is the purpose. For every discovery of science, there is an equal and opposite revelation of philosophy. Quantum mechanics revealed that observation affects reality. Cosmology showed that time itself began with the universe. Information theory whispers that reality may be computation, it from bit. And consciousness reminds us that all of it, no matter how vast or mathematical, is experienced through awareness. When these threads are woven together, they form a single tapestry. The story of nothing becoming something in order to know what it means to exist. The symmetry is almost divine. The total energy of the universe appears to be zero. Positive matter balanced by negative gravity. Creation did not violate conservation. It fulfilled it. Existence and non-existence cancel out perfectly, like equal and opposite notes in the same chord. In the grand arithmetic of being, the sum total is still nothing. But within that balance lies infinity. The infinite ways that nothing can rearrange itself into beauty, complexity, and life. It is here, at the end of the journey, that science and spirituality begin to speak the same language again. Both whisper of unity, of interconnection, of the inseparability between observer and observed. The mystics called it oneness. Physicists call it the quantum field. The labels differ, but the truth they gesture toward is the same. There is no outside, no beyond, no separate creator watching from afar. The universe is not an object. It is an experience. It is the void remembering itself through form. And perhaps, all along, we have misunderstood what creation means. We imagine it as a single moment, a spark igniting a cosmic fire. But what if creation is continuous? What if every moment, every heartbeat, every quantum fluctuation is a new beginning? The universe is not a completed masterpiece, but an ongoing improvisation. Every second it writes itself anew. Every thought, every photon, every wave of possibility is a fresh note in the song of being. Maybe that's why silence feels sacred. Why the pause between words can hold more truth than the words themselves. Because in silence, we come closest to the origin. The quiet between heartbeats, the stillness before thought. That is the echo of nothing before it became everything. And in those moments, if you listen closely, you can almost hear the void humming beneath reality, patient and infinite, waiting for the next creation to begin. Philosophers once argued about whether nothing could truly exist. They built paradoxes and proofs, each collapsing under its own weight. But perhaps the answer was never intellectual. Perhaps nothing and something are not opposites to be defined, but perspectives to be experienced. You cannot separate shadow from light, nor void from being. The one makes the other possible. When a star collapses into a black hole, when matter vanishes beyond the event horizon, it does not cease to exist. It transforms. The information it contains is preserved, encoded in the geometry of space-time itself. In the same way, when we die, when consciousness fades back into the silence from which it arose, perhaps we do not vanish either. We return to that same potential, the infinite field of being waiting to dream again. Nothing is not the end. It is the womb of all beginnings. The universe is cyclical in ways we are only beginning to understand. Galaxies are born, die, and rise again from the ashes of their predecessors. Stars collapse, scatter their elements, and those elements build new worlds. The void does not destroy, it recycles. The Big Bang itself may be only one heartbeat in an eternal pulse, a universe that expands, contracts, and begins again. Each cycle erasing and rewriting reality from the same blank canvas. And if nothing birthed everything once, will it do so again? Perhaps it already has. Perhaps creation is not linear but simultaneous, an infinite fractal of universes blooming from the same eternal symmetry, each one unique, yet all connected. Like reflections in a hall of cosmic mirrors, we look for beginnings and ends because we are bound by time. But beyond time, there are only patterns, endless expressions of the same underlying truth, that being and non-being are one continuous field. Viewed through the prism of consciousness, you are part of that field. You are not in the universe. You are the universe observing itself for a moment. The space between your thoughts is the same silence that existed before the first light. The awareness behind your eyes is the echo of the same awareness that trembled in the void before creation. When you look out at the stars, you are the cosmos reflecting upon its own beauty, wondering how nothing became everything. And perhaps that is the true purpose of existence, not survival, not progress, not even knowledge, but reflection. The void wanted to know itself, so it became a universe that could wonder. Out of nothing came atoms, out of atoms came stars, out of stars came life, and out of life came mind. And now that mind looks back, seeing the journey from both ends, realizing that it was the same traveler all along. The conclusion, if there is one, is not closure, but awakening. The boundaries we draw between creator and creation, between observer and observed, between nothing and something, were never real. They were temporary illusions, useful for the game of existence. The truth beneath them is singular. Everything that exists is one continuous expression of the same infinite zero. So what, then, is the void? It is not the absence of meaning. It is meaning waiting to be born. It is not darkness. It is light unobserved. It is not death. It is life unmanifest. It is the question that answers itself, the canvas that paints itself, the silence that sings itself into time. And what are we? We are its voice, its memory, its eyes. The fleeting moment where nothing realizes it has become aware. We are the punctuation in an endless sentence, written by no one and read by all. Perhaps the universe is not a mistake, but an act of self-recognition by nothing itself, a mirror placed before infinity, so that it could finally see what it was. And perhaps, once it has looked long enough, through the eyes of every creature, through the light of every star, it will close them again, return to silence, and dream anew. The point of light will fade back into the dark. The laws will unwind, the equations will go silent, and in that silence the void will smile, because it will know that it was never empty. It was always everything,